Today, we'll be deriving the Pythagorean identities. My name is Vay Krishnan, and let's get started. So, really, the gist of deriving all of these Pythagorean identities is just thinking about the Pythagorean theorem and our trig functions, our right triangle trig. Okay, so first of all, if you don't know right triangle trig, like basic right triangle trig, you can watch the video that I linked in the description. It's a video that I made, like, I think about a year ago from now, almost a year ago from now. And I think it clearly goes over all the concepts of or all the general concepts of right triangle trig. Definitely, if you watch that video, you will be able to understand this video. It is like 33 minutes or so. It is a long video, but I 100% recommend that you watch it. Anyway, so let's recall all 6 of our trig functions. Sine of theta. We're going to use angle theta here. I'm just going to say that this is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Okay, and the reciprocals, right? Cosecant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And cotangent of theta is adjacent over opposite. So again, you don't understand this, watch the video link in the description. So now let's draw a right triangle here. Okay, come on, I gotta make this a good right triangle. Decent right triangle. No, it's too long here. Okay, pretty solid. Not the best that I've drawn. Again, not an artist. So this is our angle theta here, and I'm going to say that this is our opposite side. This is our adjacent side. This is our hypotenuse. So now, using our Pythagorean theorem, which is a squared plus b squared equals c squared, I can denote this as a, b, and c. So, right, if we have a squared plus b squared equals c squared, we can rewrite it as opposite squared. Use a different color here. Opposite squared plus adjacent squared equals hypotenuse squared. Okay, so, but now I just want you to think here, like, looking at our trig functions here, like, what if I'm gonna actually draw some, like, arrows here. 2, 3. So, let's start off with this. What if we divided all sides by hypotenuse squared? So we get opposite squared plus adjacent squared over hypotenuse squared equals hypotenuse squared over hypotenuse squared. I want you to think about that. What if we divided all sides by hypotenuse squared? Okay, I'm just gonna draw it in order. So this arrow here, what if we divided all sides by adjacent squared? So we get opposite squared over adjacent squared plus adjacent squared, adjacent squared, over adjacent squared equals to hypotenuse squared over adjacent squared. Okay, think about that. And then here, hopefully I don't run out of room here. What if we divide all sides by opposite squared? So we get opposite squared over opposite squared plus adjacent squared over opposite squared equals hypotenuse squared over opposite squared. So I want you to think about that, like, and now you're probably asking yourself, or sorry, I can split this up into 2 fractions right here. That's what I essentially did for these other two. I'm just going to split these up into two separate fractions like I did with the other 2, right? So this is, again, I'm just going to say that this is opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. So I want you to think about this. Why did I divide by hypotenuse squared, adjacent squared, and opposite squared. Well, these correlate to our trig functions here, right? For example, opposite over hypotenuse, that's sine of theta, right? Opposite over hypotenuse, adjacent over hypotenuse, cosine of theta, right? Adjacent over hypotenuse. Hypotenuse over hypotenuse is just 1. See different color here. This is just 1, right? These will cancel. Okay. And then with this right here, opposite over adjacent, right? This is, let me write this here. This is, right? This is sine of theta, cosine of theta. And forget about the squared for a second. I'm just recognizing our trig functions here. So this is opposite square, opposite over adjacent. That's tangent of theta, right? Adjacent over adjacent, right? These cancel. We get 1. Adjacent squared over adjacent squared. We get 1. And hypotenuse over adjacent, that corresponds to secant of theta, right? This is secant of theta. Okay, and then finally, with this one, opposite over opposite, opposite squared over opposite squared, this cancels, we get 1. Adjacent over opposite, right? This corresponds to cotangent of theta, which is adjacent over opposite, which is, right? Cotangent of theta, and then hypotenuse over opposite, that corresponds to cosecant of theta, right? Cosecant of theta. By the way, we already used tangent of theta. I'm just going to highlight that there. We did use all 6 trig functions here. So now, what do you notice here? I'm going to use a different color for the highlighter here. This is squared. 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 Squared, 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 squared. So we have to, of course, square these guys. Squared, squared equals 1. Squared plus 1. Squared. This is 1 plus squared equals squared. So now we put the pieces together. Our first, therefore, sine squared of theta plus cosine squared of theta equals 1. Tangent squared of theta plus 1 equals to secant squared of theta. And 1 plus cotangent squared of theta equals to cosecant squared of theta. So sorry. Anyway, yeah, these are all of our Pythagorean identities. I was about to say all of our trig identities. That is so not true. I will try to prove as much of the other trig identities as I can in the upcoming videos. The double angle, the half angle, sum and difference, all of that fun stuff. And of course the unit circle. I still plan on doing proving the whole unit circle. That will of course come out shortly. If you're watching this in the future, all of these fun videos will be readily accessible in the playlist of understanding, not memorizing. So anyway, have a good one, and I'll see you guys in the next video.